Okay, today we're going to look at the purpose of doing the Smore Lab, and that is to introduce stoichiometric relationships that show how products and reactants are related to each other in a chemical reaction. So here are the ingredients. Here we have graham crackers. We're going to call it a diatomic graham cracker, meaning that we take one rectangle and break it into top and the bottom of our s'more. 1 graham cracker is equal to 7.5 grams, so our diatomic graham cracker is 15 grams. I just got this off the side of the packaging. A marshmallow is 0.550 grams. One chocolate piece is 3.58 grams. And that's the only ones we need masses of. So the background information on this: coefficients of a balanced chemical equation are used to see combining ratios of reactants to form products, meaning that the coefficients, remember, are the numbers in front of the balanced equations, the number that allow us to balance an equation. And once we're done with those, sometimes we have nothing, so that's a 1. But the numbers in front of each of the parts of the balanced equation, the elements or compounds, are what we consider coefficients. And those are the ratios that we have for reactants to reactants and products to products and reactants to products. There's the steps. I don't need to go through that with you. So at this point, you should have already made your chocolatey treat. And now we're going to look at the relationship or the ratio of marshmallows to s'mores, the relationship of chocolate pieces to marshmallows, the relationship or ratio of marshmallows to graham crackers, and the relationship or ratio of s'mores to chocolate pieces. And then you're going to write one that's not one of the 4 I wrote, or the reverse of one of the 4 I wrote. So let me show you what I mean by relationship or ratio. So we know in our treat we had 1 marshmallow for every 1 s'more. We had 3 chocolate pieces for every 1 marshmallow. We had 1 marshmallow for every diatomic graham cracker. I'm just following what these relationships are here. And 1 s'more every 3 chocolate pieces. So that is the relationships for those 4. Jot those down. Pause the video if you need to. And then once you get those 4 written down, make one up of your own that we used to make the treat. But it can't be the reverse or one of these 4. So in other words, you can't put down here 3 chocolates, ... 1 s'more. You need to come up with one that's not one of these 4. So pause the video and do that, and then come on back to me. Welcome back. So we can take then these relationships here, and we can make them into conversion factors. So we can take the fact that 1 marshmallow equals 1 s'more, and we can write it as 1 marshmallow per 1 s'more, or we can take 1 s'more per 1 marshmallow and write it as a ratio however we need to, because we know that's a true relationship. That equals that, or that equals that. All right, so you don't need to do that for these 3, but I hope that you can. So ask yourself, could I do that for this one? Can I write these 2 relationships for this one? Could I write the ratio or the conversion factors for a marshmallow and a graham cracker, and could I do the same for s'mores and chocolate pieces? If you can't, then you probably need to hang out with me on Tiger Time or after school and get some help. All right, so this is the quote chemical equation to make a s'more. We have a diatomic graham cracker plus a marshmallow plus chocolate making a s'more. We're going to balance it, so take a moment to balance this. Pause the video and balance this chemical equation. Hopefully you do that by putting a 3 in front of chocolate, and you know that we had a diatomic graham cracker, a marshmallow, and 3 chocolate pieces. You probably had 1 chunk of chocolate with 3 rectangles on it, and just faster to pass it out that way. And now we're going to get to the calculations and examples. So this is relating something called stoichiometric relationships, and basically we're relating the pieces of a recipe, the pieces of a reaction, and how they're related to each other. So how do we start these? We're going to scan the word problem. We're going to look for a number, a unit, and a chemical formula. So I did that here, and here is my starting amount. Okay, I got a number and I got a label or formula. We don't have a unit here because we're counting. This is 25 graham crackers, and if I was going to count 25 graham crackers, I wouldn't put a unit on it because I'm not measuring it, I'm counting it. And then we're going to some more, so we're going to start and look where we're going. So when you look for the where to go, you're looking for these question words: how many, how much, any of that kind of wording. So I call it the question word. Remember, our question words are how, why, where, how, what, where, when, and why. So in this case, how. So we're going to start with 25 graham crackers, diatomic, and then we're going to use the relationship in the recipe to go from graham crackers to s'mores. So we know there's, for every 1 graham cracker, there is 1 s'more, and if I do the math, 25 times 1 divided by 1, I can make 25 s'mores. Now, I know this is a duh, but that's the whole purpose of doing something that you can completely relate to. You would know if we had 25 graham crackers, I can make 25 s'mores based on the recipe if we followed the recipe. I realize this is easy math, but it's not about the easy and doing it in the brain. It's about having something to connect to that you can relate to. So I do need to see all this with the units and the labels, and whatever I have up here should be on your paper also. All right, example number 2. This time we have 135 chocolate pieces. So we're going to try to figure out where are we going and where are we starting. So we're starting with 135 chocolate pieces. I found the number and the unit, in this case no unit or label. We're going to marshmallows because it's by the question word, not the question mark, but the question word. So we're going to start with 135.0 chocolates. We're going to take, we know for every 3 chocolates we have 1 marshmallow. So now chocolates would cancel with chocolates, leaving me marshmallow. And because I was trying to get to marshmallow and I have marshmallow not crossed off because this chocolate would cancel with that chocolate, we now know we're done. So we're going to set it up by taking 135 times 1 divided by 3, and I get 45 marshmallows. Again, make sure your paper is complete like mine is. Example 3, we're changing now to mass of s'mores. So, whatever, 603.25 grams of a s'more. So I took all the parts of a s'more and the total mass of it was 603.25. So we're going to figure out where we're starting. We're starting with 603.25 grams of s'mores, and we're going to go to the question word. So we're going to grams of chocolate. So we're going from s'mores to chocolate this time. We're going to start with 603.25 grams of s'more, and we're going to figure out the mass of a s'more. So that is going to be 26.29. What did I do? I went back to that beginning, so let me slide back to here. Sorry, there's not a really fast way to do that. I just kind of have to click through my screens here. So I took 15 grams, so I'm going to take 15 because of 1 diatomic graham cracker plus 1 marshmallow, 0.55, plus 3.580 3 times because I had 3 of them. If I can hit my calculator keys here. And I got 26.29 for my total mass. So if this was a chemistry problem, you would get that number from your periodic table. So let me go back to that. That's where I got that 26.29. So 26.29 grams of graham cracker equals 26.29 grams of s'more equals 1 s'more. So now grams of goodness gracious. Grams of s'more cancels with grams of s'more, and I have a s'more left, so it's a counting number. Now I can go from the fact that I know in the recipe, for every 1 s'more, I need 3 chocolate pieces. This is the relationship in the recipe or the balanced equation. But I'm not done. If you notice, I have gotten at least to chocolate, right? That's what C stands for, is chocolate. But I need grams of chocolate. So if I just needed a quantity of chocolate, I would be done. But I need grams of chocolate. So I'm going to go one more time, and I'm going to say for every 1 chocolate, there is 3.580 grams. That comes from that same set of data on the front of your lab. I'm not going to click all the way back there, but that's where that comes from. So now grams of s'more cancel with grams of s'more. S'mores cancel with s'mores. Chocolate cancels with chocolate, leaving me left grams. Bam, I needed grams of chocolate. There we go. And so we're going to do this math and figure out, multiply the numbers across the top, divide by numbers on, multiply numbers across top and bottom and divide the 2. Or I like to do it as I multiply all the numbers across the top, hit equals, divide by each number on the bottom, and hit equals. When you do that, you should get 246.44 grams of chocolate. Again, your problem on your paper should look like mine, including all the labels and units and numbers. Fourth problem is similar to the third problem. We're going to take 874.9 grams of marshmallows, and that's where we're starting. And we're trying to get to grams of graham crackers. So we're going to set up our grid with 874.9 grams of marshmallows. We know that 0.55 grams of marshmallow equals 1 marshmallow. We know that from the periodic table, in this case, the front of our lab. We know in our recipe for every 1 marshmallow, we have 1 diatomic graham cracker. And then we know from our lab, give me just a sec, for some reason it's not clicking forward for me. Okay, sorry about that. So for every 1 graham cracker, we have 15 grams of graham cracker, because remember we're trying to get to grams of graham cracker. Okay, so once I do that math, I'm going to take 874.9 times 15, hit equals, divide by 5, hit equals, and you should get 23,860.91 grams of graham cracker. Okay, so like always, make sure this problem's filled out. And now let's look at problem 5. Now problem 5, problem 5, we're going to have, and yours has pluses. I don't like the pluses, so when I made this video, I changed it to commas because the commas would make more sense. So we have 30 graham crackers, 27 marshmallows, and 99 chocolates. I want to know what this limiting reactant, the limiting ingredient, and how many of the excess reactants or ingredients would be left over. So limiting reactant means what ingredient or what reactant is used up, therefore preventing us from making any more of whatever we're trying to make. The excess reactant or ingredients would be whatever's left over in the end that we have extra of. So we would need and I do realize that you could probably figure this out by just looking, but that's not what this is about. This is about understanding the math using something that we could just do in our head and then understanding the math from there. So we're going to set up 3 grids, taking each of them to making a s'more, one single treat. So we have 30 graham crackers, 27 marshmallows, and 99 chocolates. Hopefully you already maybe can see without doing any math that marshmallow would be our limiting reactant, but we're going to prove it mathematically. So we're going to use our relationships in the recipe to say 1 graham cracker, so graham cracker cancels, goes to 1 s'more, 1 marshmallow to 1 s'more, and 3 chocolates to 1 s'more. So that's the relationship in that balanced equation. And here I would see I'd produce 30 s'mores if I start with 30 graham crackers. I could produce a max of 27 s'mores if I have 27 marshmallows. And I could produce a max of 33 s'mores if I had 99 chocolate pieces. So let's talk about which one's our limiting reactant. Our limiting reactant is marshmallow because it only makes 27, right? So that would be a limiting reactant, or the thing that's used up. Once I have no more marshmallows, I can't make those treats no more. Not like following the recipe, at least. All right, this talks about the excess or remaining. Excess and remaining really mean the same thing. To get the excess, we got to take the starting amount of what we have minus how much we used up, right? So we started with 30. We made 27 because the marshmallows allowed us to make 27. So we had 3 remaining graham crackers left over. Excuse me. For marshmallows, we started with 27, used 27, so we had none left over, and that's what our limiting reactant is. And then with chocolate pieces, we started with 33, we used 27 of them, and so we had 6 remaining left over. So that is how we look at remaining actives. Now, for the rest of the lab, you're going to follow suit like we did here and come up with these. So number 1, you should be able to do a grid and get 180. Please do it and then check your math. Don't just write your answer down because you won't know if you're doing it right if you just slap it down and write an answer. You need to go through the calculation on your own. All right, so if you have any questions, don't hesitate to come see me during Tiger Time. Have a great rest of your day. We'll talk to you soon.